Bounding complexity. I guess it said encapsulating, but I changed it. So what I want to talk about, I want to just introduce a little about RMS, the company I work for, and I've worked for 14 years now, Risk Management Solutions. A little bit about the state of its software back when I started on this, and a little bit about its culture, because I think that's very important to the success or the vicissitudes, at any rate, of this journey. And it's been a long journey, so trying to prepare for this talk, I was going over all this stuff from 2007, 2008, 2009, remembering a lot of battles. So I'll be hitting these areas. So Risk Management Solutions, they were founded almost 30 years ago by a business student at Stanford Business School, and his father, who was a distinguished professor of civil or structural engineering, and a few of their friends to do catastrophe modeling, which was very new at that time. There was one other group led by Karen Clark, who was around the same time. She may have been a few months earlier, but it was a very small community back then. Over the last 30 years, for much of that time, they've been the leading catastrophe modeler for the insurance and reinsurance industries. This has been a very profitable and profitable to RMS and important to the industry, because in the insurance industry, if you think of life insurance or fire insurance, depend on the law of large numbers, basically, and that things are basically normally distributed. If you have 1 million people, you know how many are smokers, you can guess how many are going to die in the next year if you want to be kind of cold-blooded about it. But those methods are just useless for catastrophes, for things like earthquakes, hurricanes that are very severe and widespread. They don't just hit your house, which there's some chance that a fire might hit your house. But if an earthquake hits your house, it could well hit thousands of houses in the neighborhood. They're also low frequency, so there's not enough history to really help you build up much intuition as to how much you should charge, how much money you need to have in reserve, whether you should take or not take a particular risk. So the model results help insurers, and in particular reinsurers, in I list 3 key areas there that are sort of technical. But do I want to underwrite this risk? How much should I charge for it? How much can I write in a particular area? So I won't read this. This is Wikipedia's definition of catastrophe modeling. I just like to point out that it's at the confluence of actuarial science, engineering, meteorology, and seismology. There's a lot of models involved. And the sort of genius of the people who started the company was understanding that, getting together the people to do it, and creating something of value. And as someone who's worked at a number of companies that had great technology, but I couldn't understand how they were going to make money, this was really great when I came there, because it made sense to me that people would pay a lot of money, certain people would pay a lot of money for this. So this curve, I just want to say very briefly, this is kind of what it's all about. This is called the Exceedance Probability curve. It's not just in risk management, but basically that curve is the probability that the loss, I don't know if you can see, P sub I is on the left, it's probability, and loss is is the x-axis. And that point on the curve is the probability that the loss exceeds a particular value. So from this curve, you can compute all sorts of things that insurance and reinsurance companies want to know. For example, the area under the curve is called the average annual loss, or pure premium. The area to the right of the curve, the tail of the curve, is where all your catastrophes happen, all these very low probability, very high severity events. And by kind of integrating that area, you have a sense as to what your loss excess of your average annual loss is. And at any rate, the key for a lot of these models is to efficiently produce this curve from various, how much it is in terms of ground-up loss, how much it is to the insurer, how much it is to the reinsurer, not just at the level of a particular contract, but maybe at the level of a building, at the level of a portfolio. It's a lot of calculation. So here's a highly simplified view of how we generate those EP curves. We take exposure, that's the client's data, or in the case of reinsurers, the client's data, which are a definite descriptions of all the buildings that are covered by the insurance contracts and all the terms and conditions of the insurance contract. We feed it into a big box called the detailed loss model, which runs the catastrophe model, reads gigabytes of model data, which is our system data, and produces results from which EP curves are calculated and then metrics calculated on that. And we have this detailed loss model can run hurricanes, earthquakes, floods. There's one model for Guam. I don't know why. Nobody knows why, but somebody built it around 20 years ago, and we still support it. So, I won't go into detail, but basically, any CAP model has kind of three parts. It has the hazard module, which contains the hazards, the perils, the events that will damage the buildings, and their as it says, their distribution intensity. This is all done as probability distributions. A vulnerability module, which describes how a particular set of building characteristics will be affected by a hazard. In other words, these models are actually very simple. I mean, they're very complicated to build, but they get compiled down to one or two parameter things. So it's like the force, the earthquake. You end up computing, you know, the sort of force at this point in this direction. For wind, it's the direction and peak severity of the wind for hurricane, for example, at each point on a grid. We feed in the exposure data, that is the client's data. We compute what the probability distribution of the damage is, and then we apply the financial terms and conditions. So, you know, there's a lot of science, there's a lot of engineering, and there's a lot of guesswork in doing this. But, you know, our customers find it useful. Every so often there'll be a catastrophe, which is very bad for everyone. It's usually kind of good for us from a business standpoint because we get a lot of data to help recalibrate our models, and all our customers go, oh gosh, we really need models, whereas when nothing bad happens for a long time, they go, we're fine. So that's sort of the company, the business. So what was the code like back then? Well, it wasn't good. And there was a lot of it. In particular, the financial model was very big, and it was totally intertwined with the computation of the ground-up loss. I remember asking the the lead developer for the financial model. So where is exposed limit calculated? And he says, well, you mean for which peril? And I'm going, what do you mean for which peril? What does the peril have to do with the limit of liability? So this is my snarky slide. I don't know, everyone's probably got something like that, and if their code base is old enough. We were a .NET shop at the time, and before that we were just a Windows shop. And before that, one of the founders of the company wrote all the important stuff in Fortran, and we converted it to C. To be fair, I mean that slide is accurate, but it's not really fair, because in the late 90s there was a architecture of this big Windows app for Windows, basically, using what was considered the sort of best practice and guidance of Microsoft at that time, and that's why there's all that common CLI, C++, CLI, etc. So I won't go into this much. This is what the inner loop was. If you notice, there's you loop over regions, you loop over events, you loop over portfolios, you loop over contracts, you loop over locations, you loop over coverages, you loop over subperils, and then you get in there. And at each time, this is C++, right? You're allocating all these things just in case there'll be something there. And so a lot of times you'll do all this allocation, you get to the inner loop, there's nothing there, and then you have to free everything. I mean, it was really a mess. And inside that loop, there's what's called the heart of the model. We have this hazard, vulnerability, loss. And then this part at the end, as you're sort of exiting each loop, we compute the financial terms at each level that we have in our, what is it, Horatio said, there's more things in the universe than in your imagination, understanding. Anyway, this is sort of all the insurance we could think of at the time we built this a long time ago. But there's a lot more insurance than that. So that was 2006. I joined in 2004, and in the summer of 2006, I went to SD West and took a half-day course with the gentleman sitting in the third row, and he kindly signed the book. Gregor Hope was in that course too. It was a great thing, and I left it with that book and sort of a better sense as to what these things that I knew weren't right, in this huge, this thing was people didn't want to make changes to code. They didn't unit test it because there were so many things you had to bring in that it was just, they said, oh, we can't test this. I go, well, maybe that's, exactly the problem. So anyway, so we have all these ideas. I read the book, almost all the book, at the first time. So how did I get started? Well, I tried to identify what were the domains and how language was used in each of those domains. And a lot of them were ones that I wasn't really directly interested in, so I just sort of identified them and said, well, this thing with exposure, what is exposure? We have this exposure domain model is the name of our database. So, well, why not hire an expert? I'd met one. So in January, I brought him out to sign my book again, and which he very kindly did. But more than that, he came and gave a talk to, the CEO, a lot of higher management on more general kind of things, and higher management was very impressed. They really bought into things. Our product management was going, well, I don't know what this is. This is like, I don't know. Nonetheless, with the blessing of upper management, we agreed on a 3-day engagement. We brought Eric in, I and another senior developer, and a product manager came and to work on a scenario. I mean, this very concrete thing, as at least at the time Eric felt was what to work on. And we had access to consult with others, like the chief actuary, and then whatever we could come up with in that 3 days would just, determine sort of what we did next. I thought it was a good experience, but it was frustrating in a lot of ways. So what was good, we generated this sort of model of what exposure is and what it relates to. And we basically are informed by that in what we do today, 11 years later. And we discovered, I don't want to get into this too much, but basically that it should have been obvious, I guess, to us, but because everything was just one, I think technically it's a big ball of mud, was mushed together. It wasn't clear that we have, like I showed in that first diagram, we have these, vulnerability, hazard, vulnerability, ground up loss, financial loss, and then metrics on that. And that depending on the question you ask, there's a cost, and that cost is depending on how much of the model you have to rerun based on what you do. So that some questions are very cheap to answer. Others, if you don't have to rerun anything, you just have to, do stuff to the results. Others, let's say you change a limit of insurance, you still don't have to do 99%, 95% of the computation. You can just rerun the financial model. Well, that never, as far as I know, it never occurred to anyone in the company. Whereas other things are very expensive. So you want to try and avoid those and see if you can answer a similar question in a more cheap way. So I found this extremely valuable. And so we came out that this scenario, it turned out, could be answered in a cheap way. And this was a scenario that our product management had signed off. This is a very valuable question our customers would want to know. So we undertook a short-term project after Eric left. So I don't know if I should say this, but so product management never bought in. That part I can say. The VP of product management, this is the part I shouldn't say, came to me afterward and said, "Okay, David, that was fine, but if I ever see Eric Evans in these halls, I'm going to shoot him." Yeah. Well, oddly, he was fired, not Eric, but the VP of product management was fired about 6 months later. So, not by me, but so the domain experts, and this has happened throughout, tend to think in terms of our existing solutions. Our existing solutions at that time had been there for 15 years. There was a whole generation of people who had to work around the way we address problems. And so not just our developers, but our product management, our salespeople, and the people they sold to, all were people who were invested in this system of dealing with this not very usable. Well, it was usable. People used it and derived value from it, but nobody liked it. I mean, it wasn't easy to use. It wasn't easy to change. The other thing that didn't work, and again has sort of, I wouldn't say plagued us, but sort of, common colded us ever since, was the resistance to the idea that queries should be against the domain model, not against the SQL tables. And give us our SQL. If I had $1 for every time, I could probably retire. I've heard that. So, but nevertheless, product management, not so keen, but they went ahead with this initial development that I led on the analytics for 6 weeks, team of 6. We tried using evolutionary prototyping. That may have been a mistake because I had done it 4 or 5 times before with success before I joined RMS, but nobody was comfortable with it. And anyway, pre-agreed analytic scenario, acceptance criteria, a domain model, not a data model. And this turned out to be, on one hand, it's what I thought was the right thing, but it was very uncomfortable for the team. And agreement, not unanimous agreement, that there would be no UI, no need for a UI. We just needed to, run a console thing. So, what happened? Well, we built what we said. It worked. It did what we said. It was something of value. It's something that we don't actually have in our current system. I don't know why. But it didn't have a UI. So one thing that people may want to take from this is not everyone who says we don't need a UI realizes that when they don't get a UI, they're disappointed somehow. That certainly was my experience. The development team was uncomfortable with just sort of working without a net. It was, just trying things, seeing if they work. They said, but where's our data access layer? Where's our this? Where's our that? And I said, well, we'll build that later. Let's just work with the objects. And the devs and product management wanted a data model. They did not want a domain model. So, lessons learned. That first one is very important. I can't overemphasize that. The second one, there was a sponsor in the sense that someone said, yeah, let's do it, but nobody had bought into it. Nobody was invested in our success. They were invested in our success because they wanted whatever we did to eventually work, but they didn't, said, oh, it doesn't have a UI, I don't know, it's not, I'm hearing people aren't happy with the way of development. So that was it wasn't a career-ending move, but it wasn't probably, the best way for me to rise up a rung on the ladder there. But, they let me work on other stuff. And so the following year, I decided to take a look at the data model, right? The domain model, it was very difficult to get interest in this company in a domain model, but the data model, that was where it was. And around this time, as I said, that head of VP of product management was fired and a new one came. And I started looking at the data model, and in particular, and this is this just shows the tables and some of the relationships in the data model as it was in 2007. You don't really need to look at it much, but the colors, I just, in trying to figure out where everything was, all the green stuff is where physical descriptions of buildings are. So some of it's in this big one called location or lock, but most of it is per peril, which is kind of a problem anyway. All the pink stuff, there's 14 pieces of pink on this thing. It's like the British Empire or something. But it's that's where the financials are. And then the yellow, there's a couple places where yellow is, and that's where valuation information is. So this stuff is all over the place. And, actually this may be both a comment and maybe a lesson learned over time. My initial reaction to these things, I remember talking to the VP of software, after I was all full of righteous, righteous design fervor, and said, what is a sublimate doing on a building? Buildings don't have sublimates; they have floors and ceilings. He goes, what are you talking about? He goes, that's where I act on all that data, right? So, and it made more sense back in the early 90s when there was one model and then two models. They brought together all the data that they wanted to act on together, regardless of where it was. And if there was a building and it had, a floor and it was 10 stories and it had a sublimit, that didn't seem so wrong. It seemed wrong to me, but over time I realized that there's reasons why people do these things, and they're very smart people, and they're trying to solve the problem at hand. And I think that I know over the last 10 years I've done similar kind of things, not put deductibles right inside of, describe the building as having a deductible, but things because I have to make a decision and I need data, things that in retrospect I would say, that's not a great thing to do. So taking on the data model, the exposure data model, it had to be done, but it was difficult because it was very highly valued. And this is one of the reasons why the data model, not domain model, data model. It supported the most detailed descriptions in the industry. I mean, people used REDM to describe stuff they didn't want to lose because none of the other things either had a public schema or enough detail. That also allowed a lot of our customers to write integrations because it was an open database. It wasn't that easy to use, but people learned to use it, and so they did things with it. Some people like to just open SQL Manager and just change stuff on the back end, not through the app. And finally, it was viewed inside RMS at all levels of the company as a common currency. It's exchanged between parties. It wasn't something we wanted. We didn't want to debase the currency. So this, what I'm showing here is just a small part of a summary of an insurance policy that our parent company had that had been put together by a broker, and our parent company had as part of their insurance program with various insurance companies. They're secondary, they're regional coverages. We're owned by a global company that has an airplane somewhere because they do. They have all sorts of stuff. And the reason I'm showing it is that I mentioned earlier, it was very hard to get people to really talk in terms of insurance and what's really going on. I wanted to model, there was a lot of pressure, and the reason I was allowed to do all this was it was very difficult to change our schema, and there was a lot of interest. We have to go and support new lines of business. We have to go and support new types of insurance. We have to, we had all these big ideas, but we just weren't able to squeeze everything in, or everything we did squeeze would go and affect everything everywhere else. So I felt, well, we really need to go and find the actual contracts, because people would tell you, well, I could get you an EDM that's from this insurer, right? That was hard enough because that was real customer data. It's probably a lot harder now with GDPR, but back then you could get that. And I said, okay, I can see that, but what is it? What's the intent of it? What is the contract that's actually behind it? And that was very difficult to get. It was this I was able to get because it was from our company, and I knew someone who could ask the legal guy, the guy who had handled this contract, and he said, sure, you can have it. Over time, I was able to get several hundred insurance and reinsurance contracts. But that was almost the most difficult part of this, is like because first of all, it's very hard to get the actual subject matter expert, because even though there's expertise in the company, most of it is around the application. Then the people who do talk directly to customers are both talking to customers who deal with the application, or are just nervous about developers like me going and asking dumb questions of their clients who might get skittish. Says, well, he didn't know that. Everyone's an expert, or supposed to be an expert. So when you ask questions, sometimes they go, oh, well, how can that person be an expert if he asks questions? So I found this the most valuable thing, was just trying to see what these things were. And then once I had, the text of these contracts, or a slip from Lloyd's, I could go and, talk to a product manager who was sort of simpatico with what I was trying to do, and he could, find someone who could explain to them what this actually meant, right? Because it wasn't clear to us what some of this stuff means. By the way, this is far beyond anything that we could model in our old EDM. So after spending a lot of time looking at all these contracts and trying to figure out how to, what the words meant and stuff, I had several meetings with interested people, and some there was management and showed up there too, to talk about what I saw as problems with the EDM and lay out a case for why we should change it and ways we could change it. And this was an early one, just trying to get people to recognize that words mean different things in different contexts to different people. And the same word, or sometimes we use different words. Because insurance is global, what people will call a deductible, it's excess here, it's attachment there, it's deductible here. Well, it turns out actually attachment and deductible are not the same thing, but it took me a year and a half to find that out. Because if you Google it, they'll say they're the same thing. This new product, VP of product, came to one of these talks where I'm laying out the case, and afterwards, and I didn't really realize who he was, and I got kind of into a pretty violent argument with him. And then I found out who he was, and I went to to sort of talk to him and say, hey, just my opinion. And he said, no, look, I don't care, and that you haven't necessarily convinced me that you have the right solution, but you've definitely convinced me that you put your finger on the problem. And so he became the sponsor for what I did over the next period of time, which was to develop, and we hired a very good database programmer to help with the sort of details of it, and not just the details. She helped incredibly through this. Over the next year, developed a new exposure domain model and talked to every single stakeholder in the company and in each of the markets. It was an exhausting thing, but it's not that great, but it's a lot better than the other one, and it's what we use as our domain model. So I had a sponsor this time. This guy, it really helps. It's better. First half of this, I was just doing it by myself. It's better to do it by yourself than with people who just hate being there and don't trust it. But it's even better with. In other words, when we hired Suda, progress went by leaps and bounds. Okay, so 35 minutes in, and I'm up to 2009. And I haven't started talking about a language yet. Well, actually I am now, okay. So out of that development of a new exposure domain model. We had conceptual models and logical models and physical models. I wrote a couple of documents, one on what's called subjects at risk, which are the things that can be damaged, and therefore if you have exposure to the damage of that thing, you can take on a loss, and insurance. And at this point we got a new CTO and SVP of software, and so I'd written this document called Contracts and Layers, describing in what I felt were much more domain terms what the insurance was, and not how it paid out, but what all the parts were and what the relationships with them were. Trying to do that in language either that was used by the insurer or understandable by the insurer. And this is this idea of a layer was one of the key ones, right? You have sort of this exposure, and you have this horizontal line, which is where your exposure, where the insurer is willing to take on some risk above that up to some limit, and then he's going to take some percentage of that. So this is a very common thing, and this is what I generalize into a layer. I mean, in a way that the same thing exists pretty much anywhere where you're modeling coverage. But anyway, I'd written this 20, 30-page document, and I sent it to this new CTO. And the thing about the CTO was, A, he was a software guy, and SVP of software, and he was really a software guy, and he had been, he had worked on the Eiffel compiler with Bertrand Meyer. So he reads this, and he goes, well, this is very interesting, but reading it, it seems more like code than data to me. He said, could you make it code? And I said, yeah, I could do that. I mean, I'd taken a course in compilers 20 years before. I mean, how hard can it be? So this is a little cut off. Let's see if this is the... So this is the current grammar, right? I don't know if anyone's taken a compiler course, but these grammars are all pretty, they're not all. There's like Pratt parsers and stuff that are different, but there's, starting from Lex and Yak, well, it was 40 years ago then, so 50 years ago. There's sort of this idea of you have productions and you describe things in terms of other things using Backus-Naur notation. And this is not that different from the original one I wrote in 2009. I mean, I've added, there's stuff that wasn't there. I mean, there wasn't participations and cash flows because we didn't have that concept. But it looks pretty similar, and the original POC was written in F#, largely because I'd looked at several languages, but the nice thing about F# to me was it had this FS-Lex and FS-Yak, which are the corresponding things from OCaml, from the Lex and Yak parsers that had been written in C back in the 60s, or I think 60s even. And it also pattern matching. It was great. I wrote this whole POC in like 600 lines of F#, which was new to me. I mean, I didn't know anything about F#. So anyway, this grammar was basically based on the way I described contracts in this document that I sent to him. But I didn't really have a way of figuring out what the losses were. Which was the whole point of this thing, because we'd moved from, we were trying to move to a simulation-based model. In other words, our CAT model, which means that we did all the stuff you did in what I showed you before of computing the ground-up loss, the hazard, the vulnerability. You multiply that by the value, and you get a distribution of the ground-up loss. So now if you have this uncertainty module and you can sample that distribution, you can get a loss number, an actual loss. Well, now figuring out what an insurance contract pays is much, much simpler. And the idea behind CDL, this language I built, was it was built for simulation. It was built for just doing very fast computations of arithmetic along the arithmetic that would be implied by these various terms and conditions of the insurance contracts. So let me see, what do I got? I got 5? Okay. So so I came up with a POC. And this was, me, and then I would go every week and, go and sharpen the grammar with the CTO, who was having a great time. He was back in his old days working on compilers for him, and with a product manager who had really bought into this, and we were, going in and validating what we were doing. We're running into buzzsaw from model development, which is the people who kind of owned the methodology, because we were just sort of, like we're those two kids who, let's put on a show, but meanwhile, we're using some Broadway playhouse, and there's a union, and we're not supposed to be there. So we ended up. I spent about 15-20% of my time just going and trying to defend what I was doing. So I had a sponsor. I had the CTO, SVP of software, who was really behind this, but I had to fight my battles, and I had to fight them over and over and over. And you have to, because I was out of my swim lane, right? I mean, I was doing this. It had to be done. They weren't exactly doing it, but I mean, I remember after the product manager, who was kind of in our camp, went and talked to the applied mathematicians who work for the modeling. These people are very smart people. They have PhDs in applied math. He came back and said, well, so-and-so said she was offended by this. I said, offended? Did she say it was wrong? No, she didn't say it was wrong. She was offended because it was so simple. And I took that as sort of validation. I mean, I didn't mean her any offense, but what are you going to do? And it turned out, that we didn't get everything right, but she didn't catch any of the things we didn't get right. I mean, as we looked at more complex things, actually we didn't even find out. We hired, as this started getting more, started being sort of more legit, we hired a new VP of product management, and he had actuarial experience, and he had his own ideas, and he said, oh yeah, but that's not right. A deductible is not the same as an attachment. I said, well, what do you mean? They look the same, they seem to act the same. He goes, no, a deductible is something, it's like a haircut. You have this loss comes in, and you give haircuts, a deductible from the bottom and a sublimit from the top that reduces the claim. It doesn't ever pay anything out. It just reduces the amount that is presented to the coverages, which do pay out. And I went, oh, so when I have a limit, that actually is part of a cover term that provides coverage. It actually pays the reduced claim between its attachment and its limit, or pays some percentage of that. And so that was a very simple change for the grammar. I hadn't caught that thing, but I just had to add those two pieces. The contracts I'd written before all worked. The new ones worked. Oh, so I'm not going to be able to finish. So going a little quicker, in 2011, we hired some developers. We got a compiler engineer who went and rewrote the F# and Bison because he was afraid of memory, garbage collection. I don't know if he was afraid of it, but he didn't like it. And we had all these bake-offs, and with the model development stuff. So let me see. I wanted to. Oh yeah, this. So in 2011, after we had this compiler engineer, we had our last bake-off, and this was, and I don't know, I mean, this is just numbers, but we're like 2 to 10 times faster on every single one of these things. And at that point, the CTO said, okay, come on, guys, can we go ahead with this? And it was, I mean, the rest is it's what's in our system, what's been in our system since we went live. There's another language. I'm happy to talk to people about it. It's kind of fun, but my time is up. Thank you.